Hey guys, in this video we're going to be wrapping up Target B. So we're going to be looking at 6B.4. Our mastery learning objective is I can prove triangles are similar by applying the correct similarity theorem. So this is kind of bringing all those theorems like angle, side, and side angle, side, and figuring out which one to use in which case. So which one do I use? Well, you're going to use angle if, this is kind of just like a review of everything from Target B. So if you are given two sets of angles, one angle that's, sometimes is not marked, are the vertical angles, right? This includes vertical angles. Vertical angles, right? Those are the ones that make like that little V or that X, they're opposite of each other. So when do you use side, side? Well, when you are given the measurement of all three sides. So don't really worry about the interior. You just have everything on the exterior labeled. You have all three sides that are labeled. If you are going to be using side, angle, side, well, then you are going to be given two sides and the angle in between. So that's the biggest thing. Doesn't have to be, it has to be the angle in between the two sides. It can't just be any angle. It has to be the one that is in relation to the two sides that are also given to you. So let's look at some of these examples and see if we're able to figure out which one we want to try to prove. So looking at example number 1. First thing I see is angle. Do I have two angles labeled? No, I do have angle B and angle E, so that's one angle, but that's not enough to use angle, right? What about side, side? I do not have all three sides, so I cannot use that. But side, angle, side, let's try to use it. Do I have a side, an angle in between, and then the other side? Yes, I do. So let us look at what that looks like. So I'm going to pick my big side here. It's going to be 7.5. So I'm going to have 7.5, and I'm going to put that over my big side of my other triangle, which is right here of 12. 7.5 over 12. If we simplify, fraction does not simplify, but as a decimal, that is 0.625. So sometimes if you don't see that fraction simplify, if you want to go ahead and just write the decimal form to see if it also equals, you can also do that. So now I'm going to go back to my little side here, which is 5 over 8. And again, 5 over 8 does not simplify, but if you look at the decimal form, 6 to 5, our decimals do end up being equal. So my sides are proportional. Do I have my angle that is in between those two sides? And I already marked that up in red. So my angle B is congruent to angle E, right? That was already labeled for me. So yes, I have my two sides. I have my angle in between. Therefore, I can say that these triangles are similar by side, angle, side. So you have to not only write the similarity statement. So triangle ABC is similar to triangle DEF by side, angle, side. All right, example number 2, we're not going to cover this one, so you can go ahead and cross this off. We're going to skip that one. Example number 3. So I do have all these sides that are labeled. I don't have any angles, so I can't use angle, or side, angle, side, because those include angles. But I do have all three sides, so I'm going to go ahead and try to prove side, side. So I'm going to find my smallest side here. And my smallest side of triangle DEF is 11. So 11 over my smallest side over here on triangle ABC would be 22. So 11 over 22 simplifies to 1/2. And then I'm going to go ahead and find that middle side. So that's going to be 20 over my middle side over here, which is 40. And that also simplifies to 1/2. So far those are equal. And then my last side, my big side here, is 21 over 42. And if you were to simplify 21 over 42, that is also 1/2. So yes, all three sides are in fact equal. So when I write my similarity statement here, triangle ABC is similar to triangle. So if I went A to B, that was my red. So I have to go in order red, green, blue. So I'm going to go red, which is F, then the green, and then the blue. And the way that we can say that these triangles are similar are by side, side, side. All right, looking at example number 4, I'm actually going to skip this one so you can go ahead and cross that one off and you can flip it over to the next page, which brings us to example number 5 that I'm also actually going to skip because I don't want to do it. So we're not going to do example number 5, but we are going to do example number 6. So I don't have all three sides labeled. I see one angle right off the bat that is already labeled for me at 51 degrees. So that gives me angle T and angle V. So angle T is congruent to angle V because both of them are labeled at 51 degrees. But I also have a pair of vertical angles. So these two angles are actually equal because they are vertical angles. All right, so I'm going to go ahead and label those sides. So I'm going to say SUT is going to be congruent to what angle? So that would be WUV. And I forgot my angle sign. All right, that is enough to use the similarity theorem of angle-angle, right? Two angles are enough to say that triangles are similar because of the fact that all triangles add up to 180. So if those two are equal, that automatically makes that third angle equal. So I'm going to go ahead and say my triangle, SUT, is similar to triangle WUV by angle-angle. All right, next example here, I'm going to go ahead and scroll down to our last two, example number 7 and 8. So example number 7, I don't have any angles, so obviously angle-angle and side-angle-side are out, but I do have all three sides. So I'm going to go ahead and find that small side of 2.5, and I'm going to use my small side over here, which is 4. So I'm going to say, I'm going to put 4 over 2.5, because when you put that in your calculator, you actually get the decimal point of 1.6. Again, you could have also just figured out what the decimal is, which would have given you the same answer. Now I'm going to go to my middle side, which is 7.2, and I'm going to divide that by my middle side here of 4.5. And 7.2 divided by 4.5 is also 1.6, so that's good. I have 2 out of my 3 angles that are equal so far. And then I'm going to have 8 over 5. And 8 over 5 is also 1.6. So all 3 are equal. One of the biggest things too is remember that the numbers on top of your fractions should all be coming from the same triangle. Like if you're going from this triangle to that triangle, then you have to do that for all 3 ratios. You can't like flip the order and then say, okay, now I'm going from the little triangle to the big one. You have to keep that order the same. So now, since all sides are proportional, I can say triangle ABC is similar to triangle, so ABC would be DFE. So DFE by side, side, side. All right, example number 8. I have an angle that is between 2 sides. So I can't use side, side, side because I don't have all 3 sides. I can't use angle, angle because I only have one angle that is labeled. So the one I am going to try to prove is side, angle, side, and I'm going to go ahead and try it because of the fact that that angle is in between the 2 sides that are given to me. So if it wasn't even in the middle, I probably would not even attempt it because sometimes, like if you want to write for yourself, here's my side, here's my angle, and here's my side, here's my side, here's my angle, here's my side. If that angle was in any other position, don't even bother trying to prove it because it's not even in the right spot to prove side, angle, side, right? The angle has to be in between. So I'm going to go ahead and set this up. So I'm going to find my small side, which is 6. over my small side, which is 13.5. And when I simplify this, it ends up being 0.44. Looking at my other side here, going back to that little triangle, 8 over 18, that also simplifies to 0.44. So those sides are proportional, so that's a good start. And then we know that angle B and angle E are also equal because they are perpendicular. So angle B is congruent to angle E because they're both 90 degrees. So that is enough to say that these triangles are similar by side, angle, side. So triangle ABC is congruent to triangle DEF by side, angle, side. Okay, so hopefully now you feel a little bit comfortable with figuring out which theorem to prove. It all goes back to the name of actually what the theorem is, right? Angle, angle, you need two angles. Side, 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 you need all three sides. Side, angle, side, you need two sides with an angle in between. So make sure you just understand what each of those theorems represent, and then it should be fairly easy to try to prove whichever one in order to make sure that these triangles are similar or proving that they're not. Okay, so go ahead and work on activity 6B.4, and there's also an AB quiz. So you could work on that quiz review and then take the AB quiz. All right, good luck, guys.